Okay, so a function that interchanges, it's a word, interchanges really just means switches. So if you don't know the big word interchange, it means switch. But I'm going to use interchange because that's a math way to say switch. The input and the output values of the original function. So let's talk about what I mean by that. So if I start off with like this function right here, the goal will be to get an inverse function that is the exact opposite of what we started with. And that means that the domain, which are all of your x values, and your range are all going to switch. So if you're taking the inverse of something, it means that you're literally taking the opposite or you're switching it. Okay, so for example, yesterday, if you did like x plus 1 equals 0, you would subtract 1 to figure out, what that is, what the answer is. That's taking the inverse. The inverse of adding 1 is subtracting 1. Okay, that's what it really means to be an inverse in math. Okay, so there are 3 steps in the Genie, kind of wrote them out for you. We're going to rewrite it, solve, and then replace it with some kind of new notation that just to get you used to it. So in words, I kind of talked to you about this yesterday. Sometimes it's nice to write out in words what's going on for you to actually understand how to take the inverse of it. So when we look at this function here, it says negative 2 times x. So I'm going to write it says negative 2 times x. And then it says minus 3. So being able to read math is super important in my opinion because it helps you process and problem solve. So this reads negative 2 times x minus 3. If you can say that in your head, you 100% could get the inverse really easy because you're taking the opposite of both of those. So let me show you what I mean by that. The very first step in finding the inverse is literally switching the x and y. So this technically is a y. So I'm going to put a y there. The very first step the Genie told us is to switch this x with the y. They're literally going to switch places. So I'm going to have a x here instead is equal to negative 2, and then in purple, y minus 3. This is a good way to get the inverse function. You switch the x and y, and now we're going to solve for y. So usually we solve for x just because that's what we're used to, but for inverses here, we're going to solve for y. So I'm going to highlight, if you don't like highlighting, or maybe put a box around y to say it. You have to get y alone like you did yesterday. You had to get x alone. Now you have to get y alone. So you take the inverse of each thing. So remember over here, our last thing that we did was minus 3. So what would I have to do to move this 3 to the left side? What's the inverse? What'd you say? Adding 3. So it's always the opposite of what you are doing, just like solving yesterday. So we're going to add 3 to both sides. Again, we're solving for y. That's what we're doing to find the inverse. Now remember, I can't do x plus 3. A lot of times what I see here is 4x is my answer. That's not true. One's a variable, one's a number. So I have x plus 3 is equal to negative 2y. And we're almost done. It's a 2-step problem. Now, again, the goal is to solve for y, not x. Because what I've seen also is that people will move the 3 back. And it's like, well, you just literally did what we just did. But now again, if you go back to what we wrote out, it says negative 2 times. So if we were timesing originally, what do I need to do to take the inverse of it? You need to divide. So I'm going to divide by negative 2. Now again, you're not going to get an answer like y equals 4. You're going to get an actual function. So my final answer is going to be y is equal to x plus 3 all over negative 2. That's my answer. The goal was to find the inverse of the original problem. And here's a good way to check it. Remember, I started with negative 3. Did I end with a positive 3? Yes, I did. I started with a negative 2 times x. Did I end with dividing by negative 2? I did. So it's a really good way to check to make sure that you did it right. Okay, and now, the very last small little detail that I'm not going to be a huge stickler on the test, but I want to make sure that you do it mathematically correct because if you saw it on a test, you would know what it means. The very last step that the Genie told us to do up here was to replace y with f of negative 1 to the x power. That really just means the inverse. It's just a notation thing. So I'm going to do this. This is literally just being replaced with f to the negative 1 x power. That is just the math way to say inverse. That's all that means. Everything else is the same. I just switched it to the proper notation, but that would be my final answer. So really, it's a 3-step problem. Switch the x and y, solve for y, give it the proper notation. Make sure that you wrote it correctly. Like I said, it wouldn't be the end of the world if you left it as y. However, if you want to be the most accurate, you need to make sure you have that notation, which means the inverse. If you ever saw this on a test, you would need to know that means the inverse of something. Okay? Because if you look, you started with f of x, you ended with f to the negative 1 of x. So that just means the opposite. Okay? Questions? Okay. Now, for this next part, I just wanted to show you visually like what it means to be an inverse in regards to like a graph and like what actually is happening. So the one that we started with, our original f of x, right here, negative 2x minus 3. I graphed it for you already. So let's plot the points. So here I want negative 2, so I have negative 2 up 1, so that's that guy. Negative 1 down 1 is negative 1. 0 down 1, 2, 3 is negative 3. 1 down 1, 2, 3, 4, 5 is 5. And then 2 down 7. Okay, so all I did was I pulled some points from there. Now, if you remember what I was talking about earlier, when you talk about inverses, the x's and the y's change. So I'm going to tell you for the first round that the x and y values actually do change. They switch. And if we put it in our graphing calculator, I can prove it to you, but I want to make sure you have time at the end of the class. So what happens with this is they actually just change positions. The 1 becomes the x value now, and that negative 2 became the y. That's what it means for inverse. Remember, this is your original. This is the inverse that you just found out. And that's a good way to check your answers on a test is like putting in that inverse function and seeing if they do switch. So then this one would be negative 1, because look, if they switch, they still each other. Here, when you switch it, it's going to be negative 3. What's the y value? 0. Then we have, well, this is supposed to be a negative 5 and negative 7. Sorry, guys. These are supposed to be negative 5 and negative 7. Good, and then 1 and then 2. Remember, they all just switched. Whenever you're working with inverses, they switch. Now let's plot that one here in pink. So I'm going to put 1 down 2 is right here. Negative 1 down 1 is right here. And they're always going to cross at some point. Negative 3, 0, 1, 2, 3, 0, 5, 1, 3, 4, 5, up 1, and then up 2. So you can use your lanyard or you can just try to sketch it as best as possible here. But it's going to be a line. And you'll see kind of later when we talk about it visually, like what's going on here. But they are inverses of each other. And they're going to be symmetric over this line y equals x, which I will get into in a little bit. But I don't want to overwhelm you. Okay, domain and range of all linear functions is what? Because they go forever left, forever right, forever up, forever down. What is the domain and range of, yeah, all real numbers are negative infinity to positive. And that's for both of them. Negative, positive, negative. Because they go forever left, they go forever right, they go forever up, they go forever down. I'm also just going to write right here that this is our inverse graph, just so that you know, like if you go back in the notes. Okay, remember this is inverse here. Now again, it's definitely going to be weird the very first couple times you do this, but you will get better at it. It's different. Some people get confused because you're solving for y and not x, but it's not too bad once you actually take the time to learn the process. Okay, flip when you're ready so I know I can move on. I don't want to rush you in writing. Everyone walked out last period with their homework done, so it's pretty straightforward.
How many questions
I don't know off the top of my head. Okay, this next one, let's do it again. Now, in words, like you read it from the variable. So I'm going to put my finger on the variable. Read it. Good. X plus 3. Instead of saying over 2, divided by 2. The reason why I'm saying that is because now you want to take the opposite of those. And it does help you to write that in words sometimes. Now, I'm not saying that I'm going to have you write that. I'm having you I want you before every problem to think that x plus 3 divided by 2. So I'm going to say x plus 3 divided by 2. And the reason why I split those two up is because you go in that order but the opposite, right? You go backwards. So now, the very first step is to switch the x and y. So it's nothing mathematic. You're just visually switching. So this is going to become, remember this is a y. You're going to switch them. This becomes an x is equal to now a y plus 3 over 2. So all I did literally in pink is I changed this here and I put this y here. That's all I did. I switched them. Now, in order, remember, originally I said divide by 2. So what would I have to do to get rid of the 2? What's the opposite of dividing by 2? Multiplying by 2. So I'm going to multiply both sides by 2. And that gets me 2x is equal to y plus 3 because this goes away. Remember, the goal is to solve for y. You want y alone. So if I put my finger on y on the right side of the equation, everything else needs to move. Now, we wrote it out too. We said y plus 3, or in that case, x plus 3. What do I got to do to move the 3 away? Subtract 3. Very good. So I'm going to subtract 3 to both sides. Now, I'm going to write it away from the 2x because they're not the same. Sometimes what I've noticed, don't write this please, sometimes I've seen people write minus 3 right here. And then you tell me it's negative 1. That's not true. Write it off away from it. It's not the same. Okay? So I have 2x minus 3 is equal to y because I canceled. And you're pretty much done. You just did everything you really needed to do. The only now last step is to make it this inverse notation that in math we require you to do. So this becomes the inverse, and then everything else stays the same, 2x minus 3. It's very laggy, and I apologize.
So y becomes f -1.
Yep, and that just means the inverse of x is what that means. Okay, so f to the negative 1 power of x.
Is that a -1?
It's a negative 1, yep. F to the negative 1 power of x. We write it f to the negative 1 x. Okay? Because that just means that you took the inverse of this original problem. That's all that means. If you leave it y, it's not technically wrong. It's just you're not telling the readers. If you were explaining it to someone, it wouldn't be telling them that you're taking the inverse. It just means that it's a function. Okay, so that's why. All right, now let's go ahead and do these ones. It's pretty easy. I'm just going to go ahead and get some points from my graph. I have negative 3. Let's figure that out. 1, 2, 3, 0. Negative 3, 0. And then I have negative 1, up 1. So that's the y. Remember, this is your inverse. That's why I put this little f of x here. Those two go together. Okay, then I have 0 up 1.5, I'd say, ish. And then 1 up 2. And then 3 up 1, 2, 3. 1, 2, 3 up 1, 2, 3. 3. Now, what happens to all of the x and y values in this situation? What happens to all of the x and y values? When I come over to my inverse, what happens? They all switch. If you need to make a note here, write switch the values is what you're doing. Sorry, mine's very laggy. So 0, negative 3 then. 1, negative 1 now. 0, 1.5 becomes 1.50. We're just switching them. That's all we're doing. 1, 2 becomes 2, 1. And 3, 3 becomes 3, 3. Because when you switch them, they're the same number. Question? Okay. Go ahead and take a minute and graph that for yourself. See if you can graph the inverse. So in green here, I want you to graph this table. Because we already graphed the regular one. Let's graph the other one. see if you somewhat got the same as me. Okay, mine's a little sketchy. Yep.
For the domain range, will it always be negative?
For linear graphs, yes. So this is a linear function, yes. It's a line. Good question. So Jamil asked if it's always going to be all real numbers. It will always be all real numbers if it's linear. So in this situation, they're both lines, so yes. But if we had something that we're going to see tomorrow, which is quadratic, we might not have that situation. Okay, so that's what we got. The domain and range is all real numbers for both of these because.
Shapes that aren't lines.
So actually a good way to think about it is if it's an odd power, it will be all real numbers. If it's an even power, it will not. So x to the 1 power, which is linear, is odd, and that's why it's all real numbers. But if it's like x squared, because it's a power of 2, it will not be all real numbers. You'll have some kind of restriction. Okay? So let's talk about it a little bit, and the next page is super fast. It's so easy. Okay, looking at the examples, what do you notice about the table of values and its inverse? What happened every single time when we did the inverses? What happened to the x and y's? They switch. X, hold on, and y values switch.
Is that the X and Y?
Yeah, my computer is really laggy right now, so I apologize. I can't see what I'm writing until after. There is a special relationship with these two functions. If you take the inverse of a function, it's going to be symmetric, and I'm going to show you visually what that is in a second here. But you're symmetric over the line y equals x. And these two things are like the two things to walk away with about today. Is that knowing that the inverses are x and y's are switched, and that they're symmetric over the line y equals x. Those are important topics. Let me explain to you very quickly why it's symmetric over y equals x. So I'm just going to go up to our original function, our beginning, and I'm going to draw in my y equals x highlighted piece here. You don't have to do this, just watch. This is y equals x. This is that line. And I just told you that inverses are going to be symmetric over that line. So really what that means is if I took this piece of paper and I folded it on this line, they would become the same line. And it's true. Because watch. If I take this pink arrow right here, and I flip it over this line, it became the purple. Okay? If I take this pink right here, and I flip it over the Y, it becomes the purple. Okay, so that's what it means to be symmetric over the line y equals x. I was just visually showing them something. Okay, so, but we were right here, if you did not get that. And then go ahead and flip when you're ready, and this next part is going to take us 3 minutes tops. It's pretty quick. So that's what it means to be symmetric over y equals x. So when we will get more into graphs later. This is kind of just like getting your feet wet today. Tomorrow we will get a little bit more into it in the next day. Okay, easiest part of this section. It says determine if the functions and their inverses are, if the functions are inverses of each other. So we have to check to see if all of them switch. So does -2 and 3 switch to become 3, -2? It does. Like that one's good. Does -1, 6 switch to become 6, -1? It does. We're good there. And if you look at all of these, they do switch. And that means that they are inverses. So yes, inverses. So I'm sorry again, my computer is lagging, so I can't really see what I write. So they are, because they all switch. Now let's look at the next one. Does -2, -9 become -9, -2? No. And I'm going to circle this guy. Because these two don't switch. -2 becomes -13. That means that they're not inverses of each other. So I'm going to actually not put a check mark. I'm going to put no
Or an X.
instead. Or an X. You can put an X too. You can put a little X here saying that they don't. Okay, so I'm going to put not inverses. Gosh, that's really bad. I'm sorry. It's hard for me to see. So that's pretty easy. Just visually check to see if all the X's and Y's change. Last one. Given the following functions, determine the table of values that would represent the inverse function.
Don't you keep going to see if there are any more errors?
Well, as long as there's only one, like, they all have to be the same. So once you find one error, there it's not a function. Yeah. So that you don't have to keep moving on there. It's a good question. So this literally, we kind of practice this, becomes 4, -8. Because it's asking you to now make them inverses of each other. So then this one would become 5 what? Good. And then this one would be 6, 0, 7, 4, and 8, 8. Go ahead and do 3B, and I'll give you your homework. I'm going to do 2 questions with you on your homework just to make sure that you're getting it. The back page will take you 30 seconds. It's that quick. Okay? But do the next one, and very good. You can start the back while I check everybody's in because it's just like what we just did. And then we'll do 2 problems in the front. So this we switch. So you see how like it literally switched places? So then you would switch it to -2, 7, -2. And you keep doing that all the way down. Yeah, very good. Nice. Very good.
Which ones did you say you're gonna go?
I'm going to go over 1 and 4. So if you guys want to start other ones, you can. But 3 and 4 go with 1B on your notes. So if you look at your notes for 1B, 3 and 4 goes with 1B. And then 5 and 6 goes with 1A, just in case you wanted to look at your notes. All right, I'm going to go over number 1 right now. Just to make sure, it's really simple. I just want to make sure that you get it. So number 1, the very first step in these problems, remember it says find the inverse. So the goal is to get this at the very end. So I'm even going to write this out for myself now. Like that's the goal. I want the inverse of the function. So my notation's already ready to go. I just need to figure out what it is. Very first step, you're switching the x and you're switching the y. So this is going to become x is equal to 3 now y. So this is what we did on the notes. We just switched them. The second step is to do the inverses to get the y alone. Well, what is the inverse when you read it 3 times y? What's the inverse of timesing 3?
3.
What'd you say?
3.
What about 3? We're timesing 3, so what do I got to do now to get rid of it? Divide. So I'm going to divide both sides by 3. Oops. Divide by 3. Divide by 3. This goes away. Remember, the goal is to get y alone, and we're about to do that here. Because I get x over 3 is equal to y. That's it. Because the only thing that's different now, if you look at your notes, is that we just switched it to the inverse notation, and then x over 3, and we're done. So that's all we're doing. Is mentally, guys, I want you to start becoming really good at just mentally problem solving, because that's really what math is all about. It's not about equations. It's not about functions and graph. It's about problem solving and getting you used to like thinking outside the box. So here it says 3 times y. So to do the opposite, I have to divide. Well, look, my answer had dividing by 3. Check. It's a great way to figure out if you did it right. Now I'm going to do number 4 with you to make sure that you truly get it, because I think 4 is the toughest of the bunch, and I just want to make sure that you're getting it. So remember, I'm always going to end with some kind of inverse notation like this. I just need to figure out what it is, because the goal is to get the inverse of the original. Very first step, switch the x and y. That's what I'm going to do. So this now becomes an x, and then everything else stays the same, but now I'm going to have a y instead of an x. So you're switching the x and you're switching the y. This is like 1b on our notes. Now, I'm just going to kind of show you what my brain does when I do this problem. I know that the opposite of dividing by 7 is multiplying by 7. So my end result should have times 7. I know that the inverse of subtracting 4 is adding 4. So in my end result should be a plus 4. I know that -2 times y, the inverse is dividing by -2. So knowing that, you should have divide by -2, multiply by 7 and add by 4 somewhere in your answer is going to be a great way to check your work. And now you'll see here if we get that. So remember, what is the very first step to solve for y in the situation? Yeah, multiply by 7 to get rid of the 7. The goal is to get y alone. So this is gone. And I am left with 7x is equal to negative 2y minus 4. Remember, the goal is not to solve x. The goal is to solve y here in green. So would I add the 4 first or divide by negative 2? Which one would be the first step if you were solving for y? I would add the 4. Add 4, add 4. Because again, the goal is to undo everything until y is alone. Now, remember, I put the 4 off to the side because you can't add those together. I see that so many times. So I get 7x plus 4, you just rewrite it, is equal to negative 2y. And we have one last step. How do I get y alone? What do I do to both sides? Yeah, I divide by negative 2. And that is going to be my final answer here. Because you get y is equal to 7x plus 4 over negative 2. Now, remember what I told you. I'm just really trying to train your brain to think mathematically. I told you we should have times by 7, and look, we do. 7 times x. I told you we should have adding 4. We do, adding 4. I told you you should have divide by negative